Hi guys, today we're going to go through every equation in the Cambridge AS and A-level physics syllabus. One or two of the equations are not needed until the 2016 syllabus, but I'll point them out as we go along. Okay, firstly, from Newton's second law, F equals ma, where F is force measured in newtons, m is mass measured in kilograms, and acceleration is in meters per second squared. Okay, next one, we've got change in pressure is equal to the density, rho, of our liquid times by gravitational acceleration times by delta H, which is a change in height. The change in pressure is in newtons per meter squared, liquid density is in kilograms per meters cubed, and change in height is in meters. Oh, and gravitational acceleration is meters per second squared. Work done, which is measured in joules, is equal to pressure, which is in newtons per meters squared, times by a change in volume, which is meters cubed. Kinetic energy, which is measured in joules, is equal to a half times m, which is for mass in kilograms, times the velocity squared, which is in meters per second. Work done, which is measured in joules, is equal to the force, which is measured in newtons, multiplied by displacement measured in meters. The change in gravitational potential energy, measured in joules, is equal to mass in kilograms times by gravitational acceleration, which is in meters per second squared, times by the change in height, which is measured in meters. Power, which is measured in watts or joules per second, is equal to the work done in joules divided by the time, which is in seconds. Power, which is measured in watts or joules per second, is equal to the force in newtons multiplied by velocity, which is meters per second. Wave velocity, measured in meters per second, is equal to frequency, which is measured in hertz or per second, multiplied by wavelength, which is measured in meters. Intensity is proportional to amplitude squared. This is the equation for the Doppler effect and is only required from 2016 onwards. The frequency of the observer, measured in hertz or per second, is equal to the frequency of the source times by the velocity of the wave. Okay, so this is the velocity of the wave divided by the velocity of the wave plus or minus the velocity of the source, where velocity is measured in meters per second. Wavelength, which is measured in meters, is equal to the distance between the two slits, also measured in meters, times by the fringe spacing, measured in meters, divided by the distance between the slits and the source, also measured in meters. The distance between the slits, d, is measured in meters. With the angle where the bright fringes occur, n is an integer, which means a whole number value between 1, 2, 3, 4, etc. And we've got lambda here, which is wavelength measured in meters. Electric field strength, which is measured in volts per meter or newtons per coulomb, is equal to V, the potential difference in volts, divided by D, the plate distance or the plate separation measured in meters. Charge, measured in coulombs, is equal to current, I, measured in amps, times by time, which is measured in seconds. Again, this equation is not required until the 2016 syllabus. The electric current, I, is equal to the cross-sectional area times by the number of electrons per unit volume times by V, the drift velocity measured in meters per second, times by Q, the charge of an electron. Potential difference, measured in volts, is equal to the work done, which is an energy, so it's measured in joules, divided by charge measured in coulombs. Power, which is measured in watts or joules per second, is equal to the potential difference measured in volts times by current, which is measured in amps. Power, which is measured in watts or joules per second, is equal to the current squared, which is measured in amps, times by the resistance R, which is measured in ohms. Potential difference V, measured in volts, is equal to I, which is the current measured in amps, times by R, the resistance, which is measured in ohms. Resistance, which is measured in ohms, is equal to the resistivity, which is measured in ohms per meter, times by length, which is measured in meters, divided by cross-sectional area, which is measured in meters squared. The next set of equations are only required for the A level. Velocity, measured in meters per second, is equal to the radius in meters times by the angular velocity, which is in radians per second. Acceleration, which is in meters per second squared, is equal to r, the radius measured in meters, times by angular velocity squared, which is equal to radians per second. Acceleration, measured in meters per second squared, is equal to velocity, which is in meters per second squared, divided by r, the radius, which is measured in meters. Force, which is measured in newtons, is equal to mass in kilograms times by the radius in meters times by omega squared, which is the angular velocity measured in radians per second. Force, which is measured in newtons, is equal to mass in kilograms times by velocity, which is meters per second, squared, divided by the radius, which is measured in meters. Force, which is measured in newtons, is equal to big G, the gravitational constant, times by m1, which is measured in kilograms, times by m2, also measured in kilograms, divided by r squared, which is measured in meters, and that's the distance between the centre of the two bodies. Gravitational acceleration is equal to the universal gravitational constant times by m, a mass measured in kilograms, divided by r squared, where r is the radius measured in meters. Gravitational potential is equal to minus the universal gravitational constant times by mass measured in kilograms, divided by r, the radius in meters. Pressure, measured in newtons per meter squared, multiplied by volume, which is meters cubed, is equal to n, and the number of moles, times by r, which is the universal gas constant, times by temperature, which is measured in kelvins. Gas pressure times by volume is equal to 1/3 the number of molecules times by the mass of each molecule by the mean squared speed of the gas. K, the Boltzmann constant, is equal to the universal gas constant divided by Avogadro's number. Temperature in Kelvin is equal to the temperature in degrees plus 273.15. Internal energy is equal to heat energy plus the work done on the system. Acceleration is equal to minus the angular velocity squared times by the displacement from the rest position. Displacement at time t is equal to the maximum displacement times by the sine of the angular velocity times by time. Velocity is equal to the maximum velocity times by the cos of angular velocity times by time. Velocity is equal to the plus minus angular velocity by the square root of the maximum displacement squared minus displacement squared. The intensity of X-rays emerging from an object is equal to the intensity of the X-rays as they enter the material to e to the power of minus the linear absorption coefficient of that material multiplied by the material's thickness. Force in newtons is equal to the charge 1 in coulombs multiplied with charge 2 in coulombs divided by 4 pi epsilon naught, which is equal to the permittivity of free space, times by r squared, which is a distance measured in meters. Potential is equal to the charge divided by 4 pi epsilon naught, which is the permittivity of free space, times by a distance r. Capacitance measured in farads is equal to the charge in coulombs divided by potential difference measured in volts. W, the energy stored in a capacitor measured in joules, is equal to a half times by the charge measured in coulombs times by the potential difference measured in volts. The energy stored in a capacitor is equal to a half times by the capacitance times by potential difference squared. The force on a conductor is equal to the magnetic flux density times by the current times by the conductor length times by the sine of the angle between the conductor and the plane of the magnetic field. Force is equal to the magnetic flux density times by the charge on the particle times by the particle's velocity times by the sine of the angle between the velocity and the magnetic field vectors. The Hall voltage is equal to magnetic flux density times by current divided by n, the number of charge carriers per meters cubed, times by T, times by the electron charge. Magnetic flux is equal to the flux density multiplied by area. RMS current is equal to the peak current divided by the root of 2. Number of turns on the secondary coil, number of turns on the primary coil, is equal to the voltage on the secondary divided by the voltage on the primary, which is equal to the primary current divided by the secondary current. Photons energy is equal to Planck's constant multiplied by the frequency of the photon. Planck's constant multiplied by the frequency of the photon is equal to the work function plus a half times the electron mass times by the maximum velocity of the electron squared. The Debris wavelength is equal to Planck's constant divided by the momentum of the particle. Planck's constant multiplied by the photon frequency is equal to the energy level 1 minus the energy level number 2. Energy in joules is equal to mass in kilograms multiplied by the speed of light squared. In any nuclear equation, the number of nucleons is conserved, the charge is also conserved. The rate of decay is equal to the decay constant multiplied by the number of parent nuclei. The number of remaining nuclei is equal to the number of initial nuclei multiplied by e to the power of minus the decay constant times by time. The decay constant is equal to 0.163 divided by the time for one half-life in seconds. Well, we made it. There's a lot of equations there. You're going to have to cram them somehow. Good luck in your exams. Don't forget to subscribe. Bye for now.